Take a look at this question with me. We have iron, it's 35 grams, and we're at 62 degrees Celsius. It's going to be placed in 3,200 grams of water at 25 degrees Celsius. Now you know that the higher temperature is going to drop and the lower temperature is coming up. We want to calculate the final temperature that the two are going to be at. Well, in order to do this, we know that the energy, in this case, of course, heat is the transfer of energy lost, is going to be equal to the energy gained. Now, you're going to watch other videos where they use, for what's losing energy, they'll assign it a negative sign, and what's gaining as a positive. I like to teach calorimetry and the heat equations where we take the negatives out to make it less confusing. Instead, what I'm going to suggest is the side where we're losing energy, where, in other words, where we have the high temperature, we're going to do this. We're going to have Q, which is equal to MC delta T, but we're going to have the high temperature minus our final temperature, sometimes also known as equilibrium temperature, equal to MC and E final minus the low. And this way, low temperature. This way we don't have to worry about that extra negative sign. Why don't you pause the video, plug all your numbers in, solve, and come back and check it out. Let's go ahead and plug in all of the values for the setup for this problem. And what do we have? We have iron, which is starting at the higher temperature between the iron and the water, and then the water at the lower temperature. Once you have the equation written down, all you're going to do is plug the numbers in where they belong. You're going to have all of your iron numbers here on the left because that's the high temperature and it's going to drop down. At the same time, in this case, all the water information, the numbers and the units on the right, because that is starting at 25 and it's going to go up. You can see here on this next line, I have everything written out exactly the way it belongs. Of course, I'm missing the degree symbols for Celsius because I'm just kind of working through this in a paint program on my computer, so I apologize for that. And now, work it out. The answer should come out to 26 degrees Celsius. Move the numbers around for yourself and solve for the final T. If you find that you are not getting the same answer, then you want to take a look at the steps. Slow down what you're doing. Stop plugging everything into the calculator all at once and solve in steps. I suggest that you rewrite the numbers, leave the units off. You can even make TF instead of TF. You can make it X if that makes it easier for you to see the algebra to solve the problem. Keep working hard and good luck.